Hey everybody, this is Larry. This is day 5 to Leetcode Daily Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this firework behind me. Alright, bye-bye. Hope you like the intro. It is 4th of July here in New York. But of course, it is the day 5 of the poem because it released at like 8 p.m. or something. So anyway, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. No updates today. Just let's go to the farm. I ran a couple of miles, but that's it. Just kind of keep it lazy, keep it easy, keep it, I don't know, keep my energy level up. Today's farm is 2058. Find the minimum and maximum number of nodes between critical points. Okay, a critical point in the linked list is defined as either a local maxima or a local minima. Local minima if it's strictly greater than the previous, so it's like, whatchamacallit? Well, the one of them is the local maxima is the peak, and then the other one is valley or something, right? I think sometimes I don't know. It doesn't matter. Okay, So then now note that a node can be a local minimum maxima only if there exists both a previous node and the next node. So it cannot be the last node or the first node. Okay. Given a linked list head, return an array of length 2 containing min distance, max distance. Okay, so just 2 critical points, right? So it's just minimum is just keeping track of it. I mean, I think some of these problems you don't always have to try to be too clever, right? Here you can think about it in terms. I think you can think about it in terms of arrays, and it's just fine, right? It's just that you have to think about it a little bit more carefully, but not a big deal. All right, let's implement this. So I always do this regardless in general, just because it makes so many things easier to do, assuming that I do it correctly. And then current is you go to new head, and then while current dot next is not none. So basically what we're doing is actually we're tracking of current dot next, not current. And the reason why we're doing current, though, even though current dot next is what we operate on, is so that we can actually have access to the parent, which in this, well, not parent, the processor. Which in this particular case is pretty helpful, right? Because then now you can say if current dot value, I want to say if current value is greater than, is it strictly greater than? Okay. Current dot next dot value and current dot next dot value is greater than current dot next value. But here of course you have to do some checks, right? But this is conceptually fine. The only thing is that the sentinel value isn't very good here, because the -1, even though it should not affect the max, local maxima, but it does affect the local minima. So there are some things here, but I think we can also just get rid of that by going current is current dot next by skipping the first element, right? Because the first element cannot be by definition. And here we do have to add in a check, or maybe we can just do like this, because if next is none, then current dot next is already going to be or current dot next is not none, then you're already done, right? But I think we have to also consider that there is a case where so you have to do something like this. Let me think. I think the edge case, sometimes you have to be really careful about these things, because there are edge cases, right? For example, if there's only one node, then what happens? Well, then now this is going to be on the first node, and current dot next is none is fine, but you want to make sure that you don't make mistakes on like current is none, because then it will just return a no. What's it called? Something is not a property of none or something. I forget what its exact wording, but yeah. So then now this is a local minima, this is a local minima, and also this is the other way as well, right? So one of these two, So basically, we want to keep track of the minimum and the max. Does it always have one? Oh, if there are fewer than 2, then we turn -1, right? Okay, so then now we have maybe min is equal to infinity, and max is equal to just -1, maybe, right? And then here, yeah, I guess it's, you have to keep a counter maybe. So yeah, so maybe counter is equal to 0, or like position, maybe that's a little bit better word. And then now, yeah, and then maybe like a first critical is equal to so what I'm thinking is I'm debating between just writing none or some sentinel value, but I don't know that. So first, so you want the first for maximal, because in the, so for the maximum distance, you want to be greedy, which is that you want the first and the last. I mean, I think that's how greedy works. And then for that's for max, so then you could just write so this is probably like infinity, which should be fine. Actually, I should define infinity actually. And then last critical is equal to and for the previous critical maybe is more clear, just because maybe last doesn't sound right. And this you can also choose. Oh, see, here you're trying to minimize, so then here you can just write like -1 or something like this, maybe. Yeah. No, not quite. Negative infinity is probably a little bit cleaner. Okay, so then now this is critical, right? So maybe critical is equal to, just for slight readability reasons, because you could put all this in one if statement, right? But and readability is a little bit you know, but of debate, but yeah, because you get, there are different ways you can write this, so don't you know. So if it is critical, then we just write if first critical equal to infinity, then first critical is equal to is critical. You can also write min of here, but yeah, but otherwise previous critical is equal to position, right? Oh, what am I doing? This is also position. We want at the end position increment by 1, but we also want to actually do things, right? Here before we update this. So this is the update, but we actually want to do things. And the doing things is to update the min and the max, right? So the min, we want it to be, what do we want the min to be? Min is going to be the min of the min and also the position minus first critical, right? Oh, no. The min is this is the max. So yeah, so this is the max for the first critical. I mean, we could win whichever way, but the min is actually just min of min and then position minus last or previous critical, right? Because the idea is the max is going to be, you know, you spread it out as far as possible, the first and the last, and the min is just going to be adjacent critical points, right? So that's basically the idea. And then now maybe if min is equal to infinity or greater, then we return -1. Otherwise we return min max, right? In that order or the other one order? Hopefully I don't make a silly mistake. And well, I do make a silly mistake, which is that it is going to be infinite loop because I forget to iterate. It costs 10 seconds, which is, you know, on a whatever is probably fine. But, you know, if this was on a contest, that's a little bit sad. Let's give it a YOLO submit. Looks good. Yeah, that's pretty much it. I mean, I am curious what I did last time. I'm always curious what I did last time. I did the lazy cheating thing, which is fine. Was this during a contest? No. Why was I so lazy doing these? If it wasn't during a contest. Maybe it was during a virtual contest, if I have to guess. Was I on a trip that during that period? I don't know. Might have been actually. But in any case, yeah. Because usually during daily problems, I usually try a little bit. The only way I do this is this is actually it's just very lazy, but during contests it's it probably, I mean, as you can see, this took like 8 minutes, so that's a little bit slow. I mean, even if it wasn't that slow, it's just harder to make mistakes for me, just because by sheer practice. Because you very rarely use linked lists in competitive. But yeah, this is gonna be linear time, constant space. We don't manipulate anything. We just have a couple of pointers. We update some numbers, and that's it, right? And we look at every point once for obvious reasons. And that's all we have for this one. Let me know what you think. Have a great holiday if you are doing it. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.